So today we're going to prepare some benzaldehyde through the oxidation of benzyl alcohol. The oxidant in this case is going to be nitric acid, diluted nitric acid, and a catalyst amount of sodium nitrate. First of all, we have to make a dilution of our concentrated nitric acid to reach a concentration of about 1.59 molar. And then inside the hood we prepare a round bottom flask, 500 milliliters, inside a crystallizer dish with some water, so we can start after the addition of the nitric acid, we can start the heating the solution. So first of all, we're going to add the concentrated nitric acid solution into our water. Then with strong stirring, we're going to add the catalytic amount of sodium nitrate. As we can see, some vapors of nitrogen dioxide are being liberated. So it's important to carry out this reaction in a fume hood or a well-ventilated area. Next, we're going to add the 79 milliliters of benzyl alcohol. So for the reaction to take place, we have to heat the reaction to around 90 C for at least 4 hours. As we approach the desired temperature of 90 degrees centigrade, we can start see the formation of bubbles of nitrous oxide, and also the changing in color from whitish to yellow or orange color at the end of the reaction. So let's talk about the mechanism of reaction. In the first step, we have here our sodium nitrate and nitric acid. So sodium nitrate is going to take a proton from nitric acid, then creating sodium nitrate and nitrous acid. Then nitrous acid in an acidic media is going to take a proton, it's going to protonate, and it's generating this positive charged form. So water leaves, and then we generate the nitrosonium ion that it has these two forms. Then nitrosonium, we have nitrosonium here in the second step of the reaction. We have nitrosonium and benzyl alcohol. Then benzyl alcohol, its oxygen is going to attack the nitrogen from the nitrosonium. So we have here the following structure that is charge positive. So in this case, water is going to take a proton from here, and it returns its charge, generating the acidic media. And then we have this molecule that it is called benzyl nitrate. Benzyl nitrate is unstable, and it's more unstable in an acidic media, so it becomes protonated here in this intermediate. So this part of the molecule leaves, it turns its charge, and we have our final product, that is benzaldehyde and HNO. This form is going to further react with nitric acid to form another two molecules of nitrous acid. and thus regenerating the nitrosonium, and the cycle repeats itself.
After 4 hours of reaction, we can now observe the separation of phases. The upper phase contains the spent nitric acid and the bottom layer contains our desired product. Before we can separate the phases, we need to cool down the reaction flask, and then using a separatory funnel, we can now obtain our crude benzaldehyde. Now that we have our desired product, our crude benzaldehyde separated, we can start adding saturated sodium bicarbonate solution in order to remove any spent acid. Always remember that it is a good idea to shake and bend to prevent the accumulation of gas. So after we finished washing the product, the crude benzaldehyde, twice with saturated sodium bicarbonate solution and one time with saturated sodium chloride solution, we can now proceed to set up a simple distillation, a fractionated distillation using a short path apparatus. It is the short path apparatus. So we can effectively purify our benzaldehyde.